Okay, welcome to the video number 3. And in this example here, we're still solving for x. So we've got an equation with logs in it, and we're trying to solve for the appropriate value for our variable x. Now, again, you're going to use some of the same steps you did in the previous problems, but in this case, what's different is now you have two terms on one side of your equation that both have x in them. Now, what we want to do here is we're gonna use some of the properties of logs that we learned last section. So these are the product property, the quotient property, and the exponent property. What we want to do is, before we can figure out how to get our variable out of our log function, we first need to see if there's a way to simplify the left-hand side of our equation by condensing these down into just one single log expression. Now, if you remember, from our product property, we can go ahead and we can combine the log of 2x and the log of x minus 5. If you remember, our product property said that the log of a product, so let's say the log of m times n, is equal to the sum of the log of m and the log of n. So what we're going to do here is, since we are adding two logs of the same base together, remember there's no base right here, so that means it's our common log, so this is log base 10. We're going to take 2x and x minus 5 and have those be our two values that we combine together to make the product of one single log. So when we go ahead and simplify this, we're going to get the log of 2x times x minus 5. So what we've done is we've just taken both of our terms and combined them into one using the product property. Now, just like we did in the previous example, we have our variable inside of a log right now, and we need to get that out. We're not taking a log of both sides, so we can't set this equal to anything. What we can do, though, is we can exponentiate both sides to cancel out our log function. Now again, remember, there's no base written right here, but that's because it's our common log. So we've got log base 10. So we need to go ahead and take both sides up to the power of to the base of 10 so that we can cancel this out. So we're going to exponentiate each side using the base 10. Now we get 10 of log base 10 of 2x times x minus 5. And on our right hand side, we just take 2 as our exponent, so we have 10 squared. Now, because of our inverse property, the 10 to the log base 10 cancel out, and we're left with 2x times x minus 5 equals 100. And again, here's our inverse property that we use to cancel it out. Now we've left with, this is now a quadratic equation with x that we can go ahead and use our factoring skills to go ahead and simplify. So if we take this, we want to put everything in standard form and set it equal to 0. So let's go ahead and distribute the 2x, and we get 2x squared minus 10x equals 100. We'll bring the 100 over. Now we can go ahead, divide both sides by 2, and we've got x squared minus 5x minus 50 equals 0. We can go ahead and factor this, becomes x minus 10, x plus 5. So we get x equals 10 or x equals negative 5. Now, before we can just stop and write these down as our solutions, we have to go back and check to make sure they work. Anytime you've got a quadratic that you solve by factoring, you need to take your answers, plug them back in, and see if there's any extraneous solutions. So let's go ahead and we'll take 10 first. So we get log 2 times 10 is just log 20, plus log 10 minus 5 is log 5. So we get log 20 plus log 5 equals 2. We can combine these using our product property. So log base 10 of 100 equals 2. we get 2 equals 2. That works out great. Now for -5, we get log of -10 plus log of -10 equals 2. Now, we have a problem right here. Log of a negative number is not defined, so we can't take the log of a negative number. So if we take -5 for x, that's going to give us an undefined part for our equation. So we have to take -5 and cross it out, because that becomes an extraneous solution. So -5 is not part of our solution. So in this case, x equals 10 would be the only actual solution to our problem. So again, as you go through this, you're using some of your log properties to simplify your problem, to put it in a position where you can exponentiate both sides to cancel out the log. Once you get to this point where you're just solving for x and you've gotten rid of all of the logs or the exponents, just remember back to previous chapters. This was from chapter 4 when we learned factoring, how we can find our solutions. Last step is always to take both solutions and plug them in to see if they are valid solutions or if there are any extraneous ones. So to practice this, let's go look at this example right here. So log base 6 of 6x plus log base 6 of x minus 1 equals 2. Go ahead and use the same concepts to go ahead and solve this one. Go ahead and write your answer down in the form of x equals whatever you get. Make sure you check if you get multiple solutions or if you get down to a quadratic and you factor to solve. Always make sure to check to see if any answers you get are extraneous, and then only write your final solution down as a correct one.